Hello everyone, welcome to this simulation. In this video I will demonstrate a simple project which is a switch based LED control using PIC16F877A microcontroller. In this microcontroller we have a lot of functions, but initially we are going to start with an IO, the simple input output. One is input as a switch, output as an LED. This project helps us to understand how a microcontroller reads the input from a switch and controls an LED as an output. Okay, first of all, this is the Proteus. In that Proteus I am just creating a blank page setup. I am going to pick a component. In this components mode I am going to pick the component. My microcontroller is PIC16F877A. It is an 8-bit microcontroller. Just I place the microcontroller here. First step, every microcontroller there is 5 basic connections are there. One is your crystal oscillator, so I'm just picking again, I'm just type crystal, so I'm just using quartz crystal. I'm putting the crystal oscillator, right? It has a capacity of maximum of 20 megahertz crystal, and minimum we can use 4 or 16, 12 based on our requirement. So here I'm just by default 4 megahertz. I'm also using a 4 megahertz crystal now, so just click 4. If you want 20 you can use it 20, no problem. Show all, right? I'm just, the frequency is 4 megahertz, right? So next one is 5. In the 5 basic connections, one is crystal. Second one is your reset pin. Actually here it is a master clear, the first pin. For this I'm just using one push button. So in this push button I'm just connecting, and another end is I'm in that terminals mode. I'm choosing ground. So for resetting I need to give a ground, but to run the microcontroller you need to put a supply. So like a pull-up concept, I'm just adding through one resistance. Sorry, you can also type pull-up, whatever. So have some default resistance. I can type resistor, whatever. I'm just putting on resistance and go to again the terminals mode and take the power supply and place it here and just connecting the another end. So here this power you can tell it as VCC, or simply you can make it as plus 5 volt, no problem, right? So by default this master clear pin is 1 to run microcontroller start running from 00 vector address, and it's executing continuously running. While pressing the switch there is a ground signal, logic 0 will go inside, it will reset the microcontroller. Again it start from 00 vector address once it is pressed. If I release the switch it will get reset, right? So this supply is to continuously run the microcontroller. That's why here tell MCLR bar is for reset. While giving the ground, it microcontroller resets. So crystal 2 pins, microcontroller 1 pin. So 3 basic connection is completed. Another 2 more basic connection is power supply and ground. As per pin diagram, as per data sheet, if you go with your PIC16F877A data sheet, you can have 11th and 12th pin is supply pin, 11th pin, 12th pin ground, or you have an alternate supply ground pins. In the simulation it is hidden part, so we need not to connect directly, right? It basically backgroundly it connects in the simulation itself, right? Now we are going to connect an LED and switch. For LED, just component mode, pick the component and need animated LED. So we have blue, green, orange, pink, purple, different colors of LEDs are there. So any color I can choose. For example, orange. If I choose orange, I'm just place an LED, right? So for example, if I connect an LED, I can rotate the I can able to rotate it, okay, clockwise or anti-clockwise, 180 degree, whatever you can rotate it, right? So if you are connecting LED in a simulation, you can correct directly, no problem. But if you are giving in a hardware, you must give an resistor, okay, right? Without resistance you need not to give. I am just give 1k resistance, whatever some resistance I am just put it. You can choose any resistance based on your requirement. Here 1k resistance I am using. Put on ground on another, because anode side I am just directly connected with my GPIO pin, general purpose input output pin. Similarly, here I am connecting RC naught, port C 0th pin, actually physically 15th pin number, and it is connected to the anode side, and the cathode side is grounded via the resistance. You can use 1K or minimum 330 ohms is enough. If you put 330 ohm, yes, you can also use 330 ohm resistance also, no problem, right? And this is just an LED. If I want a switch, if I want to interface a switch, again I need a switch. So here we have two types of switch. You can use a push button or else you can use a switch. Here I am using a switch. Yes, I have a switch. So I have single pole, single through, SPST. Okay, so here I switch is connected in port B0, right? And another end of the switch is connecting to the ground side, and it is a common ground, or else you can directly connect to here, no problem, right? Even it is also correct. If you are connecting this also, no problem, this is a common ground, right? No problem, it is right. So here if I press the switch, logic 0 get inside. If I release the switch, it may be logic 1 or may be logic 0. Based on the internal architecture, it may vary. That's why I need to make it 1. Pressing the button, it is logic 0, ground signal. While releasing the button, it must be 1. For this concept, we need to use an pull up resistance. So already we have selected in the list of pull up. So similarly, I use the pull up resistance, because while using the pull up concept, and we have put an power source in the opposite side, right? Plus 5 volt. That means actually logic 1 is getting inside by default. While closing the switch, logic 0 will get inside. Why? Because logic 1 is also there, logic 0 is also there. Why logic 0 will takes in the sense, current always like to flow in a resistance less path or minimum resistance path. Here there is no resistance, that's why it gets logic 0. If I open the switch, there is only one path, so there is a logic 1 will go inside. Okay, right? So this is the basic scenario and basic connection for switch and LED. Once the connection is successful, you have done with an port number RC0 as an output LED and RB0 as an input switch. Now we go for a simulation using the CCS compiler, right? In the CCS compiler, open your CCS compiler, go to file and create your new project. It asks for the location to save. Already we have an design, Proteus design is inside the folder. So I have to make one more folder. I can put it a name called code program, whatever. In that there is a file name. I can use that switch underscore LED. You must not change the extension .ccs pjt. So click save, and it's also asking for the basic microcontroller selection and what are the crystal we are going to use in the hardware, right? So here there is a lot of microcontrollers. Here PIC16F877A microcontroller is chosen, and I am just using megahertz format, 4 megahertz. Up to 20 you can use it, no problem. So this is a basic connection, and we have lot of communication protocols inside the PIC microcontroller: analog, I2C, RS232 UART communication, SPI, and you have interrupts, IO pins, timers. You can also have LCD configurations, touch screen, and RTC, CCP, CAN bus, mode bus. So a lot of things are there, but we will see in upcoming videos one by one. Now we are just going to the fuses and click power up timer. Why we are using this power up timer? Until power stabilizes in all the modules of the inside the microcontroller, it maintains the reset signal. Once the power distributes to all the internal components, it gives active and the microcontroller starts working, right? So I have done only two things. One is in the device, I have selected device, and we have given 4 MHz crystal frequency. If you want, you can maximum up to 20 MHz you can choose. Fuses, I am using power up timer, right? Just click create project. The project was created actually, and my configurations will be stored in this header file, switch underscore LED, that is the file name, right? Actually I am working .c file, it is an .h header file. If you want to know what is inside the header file, you can go to that folder and open with your notepad. You will see the configuration. Instead of calling the header file, you can copy and replace this line. Just delete that line and paste it. Instead of calling the header file, you can put the header file content here for easy verification. And one for basic thing, actually it is internal ADC is 10-bit ADC. By default it makes 16. If you are configuring ADC, it will change it to 10, no problem. And no watchdog timer. Watchdog timer is if your program is locked into an infinite loop, it will reset the microcontroller. It is while releasing the product, you can do this. While developing a product, there is no need of watchdog timer. It's a power up timer. Already said about the power up timer. This is a brownout reset based on the voltage and no voltage programming. These are the basic things I am just chosen now. If you want, you can enable it in the future, no problem. And their crystal is 4 megahertz. So this is a void main. A C program, we have a main function, and this while of true is nothing but an infinite loop. So here to do user code is there. Here I am going to put a code. How to choose the code? This is an easy way. In the right top you have help option. You go to built-in functions. There is a lot of built-in functions out there. Right. In that you can search for discrete I/O components. Whatever the ADC conversion, everything, there is examples are there. If you have things, you can scroll down, you can see lot of so that means header files and your functions are returned, and you can see here. Right. And just a minute. Okay, so there is a lot of functions available already written inside the CCS compiler. So now we are going to choose a discrete I/O. In this I/O, there is an input/output control pins are there. So if you want to choose, if you want to drive an input, you can go with input. There is page can it shows like this. This simple thing. Instead of this, you can also search via index, or you can search via general things. Input. It will show some input examples. You can see the examples how the inputs can read from the microcontroller. Here's some if condition. For example, I can copy this one, I can use it in my program. For example, just paste it. I verify with my hardware. Port B0 is the input pin. So instead of checking here B0, instead of A0, I'm just putting B0. If a button is pressed, the main thing is, while the button is pressed, ground signal logic 0 will get inside. So how will you check in the if condition? It is to check the pin. By default it is 1. While pressing the switch it is low. So I am just putting, while if the button is pressed, the low signal will get inside. So I am turning into 1. Low is false, logic 0. 0 becomes, I put the not symbol. Not symbol is making 0 to 1. So getting inside the loop. The button is pressed, the loop getting inside the loop. So similarly, from same function, we can also have an output. We can choose then different output things. I am using output underscore high. I am just copying one example. I am pasting here. Instead of A0, I have connected in a hardware C0. So here you are going to connect C0. In the program also we are going to choose C0 pin. If I press the button, C0. Else the button is released or not pressed. Okay, right. Your LED should be turned off. So I am just copy paste my same code. Instead of output underscore logic high, output underscore low. That's it. If I put this output underscore low, everything is okay. If you want to delay, you can use delay underscore ms. Ms is nothing but milliseconds for keyboard debouncing. So I'm just giving 200 milliseconds. Similarly, I'm just copying this one, and here also I'm just have 200 milliseconds. The simple code. If I press the switch, it gives logic low, and you get into the if condition and turn on the LED. If I release the switch, get into the else condition, turn off the LED. This is inside this while loop. While loop is an infinite loop, it will continuously checking. Now I am just going to show you that how the program compiles. There is, listen. So here we have a program and we have that folders. Correct. We have a program and I am showing right side there is a folder which contains the C file, header file and the project file. Still now I am not compiling the program. In a normal C, it is embedded C. Generally C program will, you are giving compile, it actually converts that C code to your machine code. that is your hex file or object row, right? I am showing lively. If I give compile, there is any errors it will show, otherwise it gives no errors, the zero error, zero warnings, build successful. Similarly, see in the folder the multiple files are generated, and one important thing is the hex file. This is the actual machine code that is we are going to load into the microcontroller to perform the operation in the hardware, right? Now the same hex file is loaded in Proteus simulation. I'm just browse and get back in the code. We have selected switch underscore led.hex, and don't forget to change the frequency of the microcontroller is 4 MHz. I'm going to use. If you are using 20, you put 20. If you are using 16, you put 16. No problem. 4 MHz. Just click OK. I have double-click the microcontroller. I have selected my hex file and 4 MHz. Click OK. That's it. So now I'm going to run the simulation. Simulation is running. The blue color shows ground, logic 0. The red color shows logic 1. Correct? And if I press the button, the LED is turning on. Actually, the orange color, maybe it will little bit dull, but if you are reducing the resistance only, it will show brightly, no problem. If I release the switch, logic 1 will get inside pin B0. If I press the switch, logic 0 will get inside the pin B0. Similarly, if I release the switch, logic 1, so if it is logic 1, press the button is not pressed, so LED is turned off. If I press the button, logic high is going into the LED, it will turn on. Okay, and this is the reset signal. Actually, reset will reset the microcontroller from, it will start executing from 00. If I reset it, again it will check for the button, it is pressed, turning on the switch. If I release the switch, turn off the switch. Right, this is the basic things, basic simulation of switch based LED control. Here simply we can understand switch is digital input, we are giving logic 0 or 1, simple thing. In this we can replace the switch with digital sensors, for example IR sensor, infrared sensors, PIR sensors, proximity sensor, in inductive proximity or maybe capacitive proximity. We can replace the switch with an sensors, and switch itself is a sensor, correct? By getting the signal from this sensor, we can control an LEDs or relays or higher end devices, or can display some values in the monitors. Everything we can do one by one, no problem, right? This is the basic LED switch based LED control using PIC16F877A. It's an 8-bit microcontroller, right? I hope you have understood the basic things in this process, right? Thank you all. We will see in the next video. Don't forget to subscribe. Thank you.